All right, it's Saturday, November 1st, 2025, and this is the first of what will hopefully be 30 daily videos in November covering how to map creation for the 30-day map challenge. So, little background on the 30-day map challenge. Here is my planner, generously provided for free by Carolina Lehotska. And I'll show where to download that in just a moment. But the whole idea here is to create 30 maps in 30 days following these guidelines from the 30-day map challenge repository. So day one is points and building a point-focused map. So the idea here is to create a map with points using individual locations, points of interest, clusters, and focusing on effective symbolization and density visualization. So what I created, this map is taking a look at US cities and the clusters that were created by a density-based clustering tool in ArcGIS Pro. So what we'll start with is just a walkthrough of exactly how to create this in ArcGIS Pro. So let me go ahead and open up the application. I've got my full cup of coffee here, and I'll do my best to edit out the sips here. But definitely essential for doing any kind of GIS work. So I've got a brand new blank 30-day map challenge ArcGIS Pro project, blank slate. You can see here in the catalog, I've got my default geodatabase, completely empty, no maps, no templates. So the first thing we'll do is create a new map and add the data to the map that we're going to be working with. And the data we're working with here is the USA major cities layer from Esri. So what Esri does is they take the US Census Places polygons and they create this point layer from it with some helpful attributes and information. So the first step is going to be grabbing this URL for the REST endpoint of the hosted feature service and adding it to our map here in ArcGIS Pro, add data from path, and add the hosted feature layer to the map. Now what I like to do, because we're still pointing at that hosted layer here in ArcGIS Pro, is do the projection and get it into our local geodatabase all in one shot by using the project tool. Because our density clusters are going to be based on distance, so it's important that we have a good projection like equal area that represents the actual dimensions of the Earth's surface and not something like the Mercator projection. So this is going to drop a new layer in my default geodatabase. My output coordinate system is going to be the USA Contiguous Albers Area Conic, USGS. And what this will do is it will transform the data. Let's just make sure my map matches that projection. Let's apply that. We should see the base map change up a little bit. But now we know that the projection for this data is equal area, so when we build clusters, we'll be treating it appropriately. All right, so here are our city points in the right projection. I'll just go ahead and remove the hosted feature layer, save the project, and the first step here is to run our density-based clustering tool. So let's open that up. And I did a lot of experimentation with the parameters here for this density-based clustering tool that we'll take a look at and a quick review of the documentation as soon as it loads up here. So our input point features are going to be our USA major cities. And our clustering method is going to be dbScan Okay, and if we take a quick look at clustering method, we can see that dbScan, a specified distance will be used to separate dense clusters from sparser noise. dbScan is the fastest of the clustering methods, but is only appropriate if there is a clear distance to use that works well to define all clusters that may be present. This results in clusters that have similar densities. So that will do for my purposes here. And what we're going to do is set the parameters first for the minimum features per cluster. So this is the minimum number of points that will be considered a cluster. Any cluster with fewer points than the number provided will be considered noise. So we're going to say 50 cities per cluster, and these are kind of arbitrary based on my testing and trying to get the results close to the map that inspired this in the first place. So we'll set our search distance to 80 miles. And we'll go ahead and run the tool. And this will output a new layer, USA major cities _ density based clustering. And I'll add the 50 and 80 just as a note that this output had those parameters. So we run the tool, and here are our results. We can see that the clusters have been formed and symbolized in color here on the map in that new layer. So if I turn off my USA major cities original layer, we can see the output of this tool and the clusters that have been created. Now, these are simply based, again, on those parameters and the particular density that was established with those parameters. So just sharing my notes really quickly here, I ran this with a lot of different parameters and got a lot of different results. You can see here, I'll just scroll through some of the screenshots. If we set it to 100 and 100, we ended up with this. If we set it to 80 and 100, we end up with this, the Northeast and the Great Lakes combined into one mega cluster. As we adjust 50 minimum, search distance 100, we can see just that expanding massive cluster. So I wanted to get something that matched the RPA map. So ran it with a lot of different parameters and ended up with this, which I thought was good for the day one map example, because it looks pretty close to what we see here. And apologies if I didn't show this at the beginning, because this is the inspiration for this first map, is a map that you're looking at now from 2008, created by the Regional Plan Association as part of their America 2050 initiative. And this map actually inspired me to move out to Colorado, because I thought there was this massive urban front range running from basically Albuquerque up into almost Wyoming, and was really excited about that. Not exactly the reality, and that's one of the things we'll get back to in the criticism of maps like this and the whole concept of generic mega regional definition in geography in the first place. So let's jump back to ArcGIS Pro. Again, just ran the density-based clustering tool, and we're looking at the results. And if I look at the attribute table of this layer, we can see that there's really not a lot of great information. There's just a color ID, a cluster ID, and then the ID of the source feature that it was created from. So in order to manage these a little more effectively, what I'm going to do is create a new field that allows me to name essentially each one of these clusters as a region that kind of makes sense, like you saw in the previous map: Northeast, Southern California. So let's go ahead and add a new field. We'll call it name, and we'll make it a text or a string field. Keep the default length of 255. So now we're going to select by that cluster ID, cluster by cluster, and give them their names. So let's just pause for a moment and think through if that's actually what we want to do, or do we want to get the names here in the original layer, because that's where our populations are. So what I think we actually want to do is put the name field in this layer, because that will allow us to symbolize just this layer in our map. So let's go ahead and add the name field here, just like we did in the previous one. Should we give it a name? Call that a text field. And we've already got a field named name, so we'll call it region. And save. So what we'll do is select by each cluster, and we'll select the point by location, and we'll calculate the field for each one of these. And then we'll jump onto the symbology. So let's start with our select by attributes. And using the map as a guide, I'm just going to go through and select from my USA major cities, density-based clustering, cluster ID is equal to 1, and then visually on the map, identify what it is. And what we'll do is we'll select from the original major cities, everything that intersects, and points are on top of points, so they should intersect perfectly. There's 154, so now I have a selection of 308. That's correct. And now I can calculate the field and give it a name. So the calculate field tool, our input is going to be USA major cities. The field name is that region field that we just created, and the value for this first region is going to be Atlanta, Piedmont. That's the name I came up with based on that RPA name of Piedmont Atlantic. So interestingly, the clustering split this Piedmont Atlantic region into two clusters. So we'll call it the Atlanta Piedmont because Atlanta is the largest city there. Go ahead and run the tool that calculates that field. And we'll move on and do each one of these. So I may speed this part up or feel free to fast forward through, but we're going cluster by cluster. So next up is Southern California. I'm just going to clear the selection each time to be safe. So next up is Southern California. We'll do our select by location, and then let's calculate this name as Southern California. All right, next up, cluster number 3, Northern California. I'm going to clear my selection. Northern California, apply the select by location, and update the name. Now this is a lot of GIS work for any aspiring GIS analyst. Watching the video here, lots of selections and field calculations. So cluster ID is equal to 4. Where are we now? That's the front range. So I'll go ahead and call that front range. And run. Clear my selection down to 5. But it's helpful to give these things names here, because otherwise we would just be looking at numbers in our list, and it would get very confusing. So this is the northeast. Okay, let's go ahead and run that update, clear the selection, move on to number 6. That's Florida. All right, so we'll give this the name Florida. Run, and if you just focus in on a particular workflow, it's not that bad. It can get a little tedious, but it's the times like this when you're working and it's so easy to get distracted because you're just so bored sometimes. All right, this is an interesting one. St. Louis got its own cluster. Didn't really expect that, especially considering the other areas like Vegas, Arizona, or San Antonio, Austin that did not get clustered, but that's what we're working with. Clear, 9. Apply, and it's so great to have a map here because you know that your selection is right. You're not just working with numbers. That's why I love GIS, because you don't get as abstracted like if you're working in a spreadsheet or something. You can actually tie the numbers back to what they represent in the real world, and it helps maintain a thread of interest through tedious, repetitive workflows. So here's the other Piedmont. I call this Carolina Piedmont because it is in the Carolinas, and that's the best name for it. Only a few more to go here. Next up, Cascadia. Again, taking most of these names from the Regional Plan Association map from 2008. All right, now where cluster ID equals 12. Let's see where this is. This is the Dallas area. Let's call that Dallas. All right. Getting close here. 13. Houston. Okay. And then 14, last one, Salt Lake. Interesting, again, that this was defined as a cluster. And run. Okay, so let's check the attribute table and make sure that all of that stuff came in correctly. And what we can do actually is hide the clusters, because now our clusters should all be defined by their name in the USA major cities region field. So, did I do it right? Atlanta Piedmont, got it. Carolina Piedmont, right there. Cascadia, yes. And I'm looking at the blue highlight for the selection if you didn't notice. Dallas, yes. Florida, there it is. Front Range, behind the window, but got it. No, Great Lakes, this is looking good. Great Lakes looks good. How about Houston? There it is. Minneapolis. All right, Northeast. Northern California. Salt Lake. Southern California. And St. Louis. Okay, great. So now we've got our clusters, and what we can do is symbolize these cities based on a few factors. And while we're symbolizing, let's switch to the light gray canvas background, turn off the reference, and open up the symbology pane for our USA major cities. And what this is going to be is unique values right? Because we're doing it by name, or we're doing it by region. So here are all our different regions, and we're also going to symbolize the cities by size based on the population. So if we go to 2020 total population, oh, what's going on here? Look at that. Look at that. Let's enable the size range. I don't know what that was about, but this looks more like what I was trying to accomplish, which is the map showing the cities colored by their region and sized according to the total population. Perfect. So let's make this 5 bins. Okay. And that's a decent starting point. I think let's bump up the maximum size actually. Let's bump that up a little bit to 120. Okay. Because that really highlights just how massive New York City is. And let's pull up the bottom range. Wow, New York is just an incredible outlier. So we'll pull this into kind of the mid-range. 8 million seems to be the breaking point. Alright, good enough for now. So few more things that I want to do in terms of just the symbology here, which is make sure all of these have no fill and have a color that matches their significance in the map. One of the things I like to do with colors is just grab the hex values for the color I want. So that's what this list is here. I'm going to be copying and pasting the hex value into the color properties for each one of these. So that was the null layer, everything that was not a major cluster or cluster at all, and then we'll go through and update these. So each one, no color properties. And these are those kinds of things where it's like, yeah, I could automate this, but I'd spend more time automating it than it's really worth. So again, another kind of tedious process. If you see anything obvious that I could be doing better, please let me know in the comments. But what we're doing here is just setting the colors for each one of these regions. And I tried to kind of match the symbology again from that RPA map because I really like the design, and you know, it's a pretty influential map. If you look at regions of the United States, it kind of is the most impactful in terms of other people referencing it. There's a Wikipedia page, there's a Reddit with hundreds of comments. So it's kind of an interesting thing to try to replicate with a more quantitative, repeatable methodology. And that's really the only thing of value in terms of what I'm doing here, is that I'm creating a repeatable methodology and I'm adhering to standards that can be followed to create the same map. Basically trying to document my process so someone else could create the exact same product and that I can come back and do something repeatable. Because if there was some theory behind why I chose those particular parameters and why a density cluster of major city locations would be important in the first place, all that's really required in order to create a map product of value and relevance for people to solve problems. I'm not there yet with this one-day map project, but what I'm doing is establishing a repeatable pattern and documenting the process, and hopefully creating something valuable for folks that are engaged in the challenge or want to know how to do some of these things relatively quickly in the application. For example, finding that the unique values and the size thing that I just did, that was a little tricky. Took a little research to figure that one out. So that's the idea. And the same thing with this hex code thing. Like, I don't know how many people do this. Maybe there's a better way to do it. So that's the idea. Again, I might just fast forward through this part of the video. So apologies if this is the most boring thing you've ever seen ever. But we're almost at the end of the list, and then we'll be left with something that is pretty much the finished product in terms of the ArcGIS Pro component of the map creation. So things are looking better. It's another thing I love about GIS work. It's like you're just cleaning up the mess and making it look better. And one of the things we want to keep in mind is that just because it looks good doesn't mean it's in any way meaningful or helpful or reflective of the real world. Those are all very important things to keep in mind, because even though I'm using the RPA map as an inspiration and as a style guide, I've lots of criticisms of their methodology. That's a research paper I'm currently working on. So, not going to get into any of that here, but just want to make the point that I understand that what I'm engaged in with creating this map is more performative than actually beneficial or useful from a scholarly, professional, or academic perspective. Yet it has utility, definitely for me, and hopefully for anyone who is generous enough with their time to have tuned into the channel. So there we go. One more, St. Louis. Did I miss them? Ooh, requested operations could not be completed. Oh, I'm so close too. Alright, well, let's see. No color. Color properties. Let's paste that in one more time. Okay. And I realize that's almost the same exact color as Southern California. They are a little different, but I could have done a better job with that map design. Alright, so now that that's done, what we can do is name the map, which is always helpful prior to creating layouts, so you know what you're putting in your layout. So we'll call this map number 1, points, because I'm going to be making all the maps in the same project and maybe even using some layers from the maps in between. So let's go ahead and insert our new layout and go in and draw the map frame. And then we'll activate the map frame, get our zoom extent right. Another tip is just using the zoom thing down there to get a little more exact. All right, and then here in the layout, what I like to do is remove the service layer credits and then save, export to a GeoTIFF. And then that's what I'll load into Inkscape to put on some of the final details. This really isn't an Inkscape tutorial, so I'm not going to go into this too much, but here's where I did the legend. It's just easier, and exported the image for the day one of the 30-day map challenge. So that's kind of what I did. Started with this map and created this map. Now, I need to do some additional work with the scale, or the size of the symbols for the city population, but that's the gist of the process here, and it's all utilizing that tool. If I go to the history, you can see what I ran here. It's the density-based clustering tool. So we can look up the documentation for that one. And here it is on the spatial statistics toolbox. And this is the in-depth description of density-based clustering. Not going to go through all that in this video. So really that's what I wanted to cover. I'm going to be doing this for the next 30 days. So this was step one, and I'm going to just check them off live as we go. For me, finished means I've already posted it to LinkedIn. Published means I've done the how-to video. And, you know, in terms of criticism, I kind of said everything I wanted to say while I was going through those tedious processes. But standard methodology, you know, this wasn't subjective. I ran a tool, said these are the clusters, lined up with kind of what I wanted, and the symbology of creating the proportional symbols, the hollow symbols based on the color, that's kind of the response to the challenge of make a maps with points and think about density and clustering. So hope this was helpful. I'm going to try to improve the quality of these as we go along, but thank you so much for your time, and I will see you tomorrow for day 2, lines, where we'll be focusing on interstate highway connectivity in between these mega regions. Thanks so much for your time.